pitch.
Ooh.
Now I got it on the bounce. I didn't forget you.
Thank you.
That's a great question.
Yeah.
Yeah, only 3 tries.
We're waiting to play baseball, so.
Don't do it hard and weak, all right?
Ah.
I did have one.
Very good.
All right. So that was how I said hi to all of you and broke the ice
Oh, thank you.
with water. So, greetings, fellow water bags. Like all of you, I am like 60% water by composition. Ecology and aquatic biology. I've worked in indoor and outdoor pools, as well as lakes. I've pushed water out of people's lungs, and I've drinking water. I mean, I pretty much am water. And just like all of you, you drink water, 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 you drink, well, you're not drinking water. You drink water, you're all hopefully drinking water. Every single one of you, literally all of you, have drinking water. And you've eaten water, even if you didn't know you were eating water, because it's in everything. In fact, none of you would even exist without water. It is in literally everything you eat. And because it's in everything you eat, water is crucial. It is essential to human life, because without it, life would not exist. And water, because it's essential to life, makes it around the earth and has been around for a millennia. Well, millennias. In a continuous, mind-boggling cycle. In fact, many of you have drinking the same water that was once blood flowing through a T-Rex. So that's pretty cool if you ask me. And why is that? That's because water is central to life. Without water, you will die. That is a known fact. You could try it, but you would die. And a human can go nearly a month without food, but only 3 days without water. Because your body is mostly composed of water. And water is used by everything you eat as part of its body and part of its structure. Do you eat meat? Guess what? Meat drinks water. Do you eat vegetables? Plants drink water. Because water is incredibly interconnected. It is so interconnected that in New York City, citizens are teaming up to collect data on water quality. And the purpose of this, according to the Science of the Total Environment, a scientific journal, volume 580's article, Citizen Science-Based Water Quality Monitoring, constructing a large database to characterize the impacts of combined sewer overflow in New York City, authored by David Farnham and many other citizens. Sorry, that was a really long citation. I had to read that one. So if that long-winded oral citation wasn't enough to tell you what the article is about, it's all about making sure that toilet water does not wind up in pool and pond water, as well as to encourage work between scientists and citizens. Because it's really amazing how much water is interconnected and gets people to bond. In fact, it's astounding how much water goes into your body without you even knowing. So now we're just going to jump to the different ways that water gets around. The first one, and the most obvious, is precipitation, in all of its glorious forms, acidic and non-acidic. Rain, as you know, rain as you already know, I really hope every single one of you knows what rain is at this point in your life. Because it's water from the sky, so how does it get there? I'll go into that a little bit later. And we're going to go over some precipitation first. Snow, it's water. It freezes in the clouds and falls to the ground. You know what snow is. It snowed last week. And clouds. Well, technically clouds are not precipitation, but in really simple terms, they are essentially large groups of evaporated water condensing in the sky until the excess weight causes it to rain. Still in the water cycle, runoff. No, not like your childhood pet, but water that goes from one body of water to another, which often picks up pollution along the way, such as oil. Because how many times have you looked at water in a parking lot when it's raining? Maybe only a few times, but you've probably noticed the little rainbow swirls in the water making it shine. That is oil that is being picked up by the water and carried off to the next body of water. Fertilizer is often in runoff. It is generally responsible for algal blooms in freshwater lakes. Many of you, if not all of you, have at some point in your life come across a pond that is nearly green from all the algae that is caused by the rich nutrients in the fertilizer that feed the algae, and that often kills most of the fish in the pond. The fertilizer is often carried by runoff from farms and gardens. From runoff to stream flow, all roads lead to Rome, as the saying goes. But for rivers, it's the ocean. Almost all rivers flow out to the ocean, continuously providing fresh water to the ocean. In fact, if any of you want an interesting and terrifying read on runoff and how it can affect you, there's an article by the Electronic Journal of Natural Sciences in Volume 26, Issue 21 from 2016, called An Attempt of Using Ecological Standards for Assessing Urban River Quality, a case study of Urmi. Yeah, it's a mouthful. The article is pretty easy to understand, and it goes over the outcomes of the studies of the mountain rivers that run through Urmi, which is the Republic of Armenia's second largest city. Anyway, that digression, even though it was totally scripted, is dumb. Evaporation. Pour water onto any hot surface and you'll notice that it disappears. Don't worry, it's not the spirit of your great-great-grandfather here to punish you for bringing dishonor on the family. It's evaporation. Water when exposed to heat, such as from a stove, hot rock, the sun, volcanic steam, evaporates. That means that it goes from liquid to a gas, and that makes it humid out. And that means that there's a lot of low-hanging water vapor, which is responsible for that near choking-like sensation which comes with high humidity. Evapotranspiration, another form of the water cycle. Now that's a fancy word for plant breath. On second thought, let's just keep calling it evapotranspiration. So that word refers to the water that plants give off when they go through the process of photosynthesis. It goes in, but it also goes out at the same time. So it's not really part of it, but it's why when you walk into a greenhouse, there's all that steam there. Sublimation, another part of the water cycle, is when solid ice becomes a gas. And it's a really fascinating process to watch. And with global warming on the rise, there will be plenty of opportunities to observe it. Condensation, another part of the water cycle. Evaporated and evapotranspirated water condenses into those giant puffballs we call clouds. And clouds are one of the many ways that water can move around so much. Because in case you hadn't known, there aren't a lot of obstacles in the sky, which means those giant gaseous goofy guys and gals can go all over the place. Now, I had hoped it was going to be cold last night, so I don't have a cold water bottle. But if some of you will look at your water bottles, you might just notice that there are little beads of water forming on them. It might not because it's really hot in here. Does anybody see this? Yeah, he's got them. Good. That is a form of condensation, which is essentially water vapor forming into water. All right. There's a lot of stuff to go over in the water cycle. So now we're on to groundwater, which is one of the most important things you may not even be aware of. But to keep it simple, so we can all go home, groundwater is any water that is in the ground. The waterways that feed into it are referred to as the water table. When you account for the groundwater, it's referred to as the water table. In some places on Earth, man was not meant to live, like Phoenix, Arizona. That place comes to mind. Now currently, Phoenix is a livable place. It's doing okay, but back in the day when people moved there in the arid desert, because it was like the 50s and the 40s, they decided, oh, we want suburban homes with nice green lawns. And Arizona is an arid desert, so that did not work out. And that didn't happen because they overtapped the water table. So they were constantly trying to bring up more water than they could actually sustain. So of course, the plants all died, and it just looked bad. And now there are ghost towns. And speaking of groundwater, if well, we can't do it because there's a carpet. But if you pour water onto the dirt will soak it up. And this is a form of infiltration, or basically what keeps the water table working. The water table depending on where you live, may rely more on rain or river flow, but either way, it needs a near constant input of water to stay all right. And groundwater flow can come out in one of two ways, in the form of springs, or into other bodies of water, usually the ocean. And speaking of the ocean, guess what? The ocean is made of water. That is absolutely crazy, am I right? Yeah? Yeah? God, I hope you knew that. So how does this giant body of water work? And why does it matter to you? Historically speaking, most major cities have been founded in a harbor or near one. For instance, New York City, Boston, Alexandria, Egypt, Antwerp, Belgium, Abadan, Iran, Rio de Janeiro, and those are just the popular ones that are still around. So why are all of these famous cities right next to the ocean? Fish. People love fish. They eat them. They grow them. Some weirdos even keep them as pets. And the ocean has provided food for mankind for nearly its entire existence. So what does this have to do with the water cycle? And why can't I just go home now? Because it's all about ocean currents. And ocean currents pretty much come down to thermodynamics and saline levels. Basically, the more salinized the water, which is how much salt is in it, the heavier it is. And heavy stuff, as you know, sinks. But cold water also sinks. And the less salty it is, the cold water. Wow, because the hotter something water is, the more salt it can absorb. So you've got this constant rush of heavy salt trying to go down, heavy salty water, and non-salty water trying to get up top. And why does that matter to you? You sit there wondering, because the basics of thermodynamics kick in. And this is basically known as hot stuff rises and cold stuff falls. So there's a constant movement of water up and down, and that creates a lot of energy. Energy goes into moving that water around the world. Because the ocean does not sit still. It's constantly moving and carries water all around the world, affecting everything from food sources to the weather. And as the Journal of the Physical Oceanography article, The Global Conveyor Belt from a Southern Ocean Perspective, from volume 38 back in July of 2008 tells us, the Southern Ocean is the main driver for the North Atlantic deep water circulation. All right, that's a little dated, I know, but keep in mind that it takes about 2,000 years for water in the ocean to do a single lap around the Earth. And as I said earlier, hot stuff rises and cold stuff falls. But as it falls, it creates a low pressure, and then the water around it also tries to go down. As it goes down, it gets cooler because it's farther from the sun, and it keeps going up, rising and falling in a circulatory motion. And that's how it gets around the world. All right, so before everyone here dies of dehydration, I will finish up. In conclusion, water is one of the most important things in your life. Water is shared between nearly all species and belongs to really no one in particular. Without water, you would die. Water has been around since before we existed as a species and will exist long after we're gone. The Earth is over 75% covered in water, most of which belongs to the ocean. The ocean has an effect on all of our daily lives, whether we know it or not.